Hello everyone, my name is Brendan and I'm with the Office of the Vice President of Research Virtual Reality Initiative. I've been working with XR technologies for several years now, and today I'm going to be showing you how to set up Unity for XR interactions, so either both augmented and virtual reality development. This is going to be just sort of the basic setup, and this does assume that you have some experience with using Unity in general, so I'm not going to be going over a lot of Unity basic stuff. We will be releasing a different tutorial for that. So the first thing we need to do is actually install packages and configure some project settings. I'm going to just shift this over here because I prefer my hierarchy on this side, but we'll go ahead and we're going to go to Edit and then Project Settings. And I'm going to just search in here Preview because I need to go to this Enable Preview Packages under Advanced Settings within the Package Manager settings. So I'm going to enable Preview Packages. This warning is basically just saying, hey, Preview Packages aren't technically finished. You might have some stability issues, but we need to enable that for the XR Toolkit. I'm going to go ahead and close that. We'll be jumping back into there later, but for now we just need to go to Window and then Package Manager. So then we'll need to choose Unity Registry rather than just in project. This will show all of the different packages that are available through sort of Unity itself. And then in here I'm going to just type in XR in the search bar, and this will show us everything that has some type of XR spin. So if you're doing augmented reality, they have a couple of different plugins for that. They have a couple different plugins for different headsets, but the two that we're really interested in right now are the XR Interaction Toolkit and the XR Plugin Management. So I'm going to go ahead and install the Plugin Management first. It will always take a moment to actually load. Once that's finished up, I'll go ahead and install the XR Interaction Toolkit. Again, it'll take a moment to actually load and install, and some of these might also restart Unity themselves. So once both the XR Toolkit and the Plugin Management have been installed, you'll need to install the plugin for whatever system you are using, so your actual head-mounted display or your mobile system. In this case, if you're using, say, Android for augmented reality, you choose AR Core, ARKit for Apple, ARKit for Apple augmented reality. Wow, that's hard to say. Magic Leap XR plugin. There is a mock HMD XR plugin for if you don't have a headset for testing. And then there's Oculus for the Oculus Rift and Quest. OpenVR for Steam-based headsets. OpenVR does also support Windows mixed reality as well as Oculus headsets, but you do have to download a separate plugin for using them through Steam. And then there is also a Windows XR plugin. In my case, I'm using a Valve Index, so I need the OpenXR one, so I'll go ahead and install that. So once all of the plugins you need have been installed, you'll just need to make sure that the proper plugin is enabled in the project settings, and you may have to configure some things. So go to Window, and then, Edit and Project Settings. And then down here, you should have this XR Plugin Management plugin that has popped up, so we'll click on that, and then you're just going to select the plugin that you want to use, in my case OpenXR. You may have a couple of warnings. If it's a warning, it's fine. If there is some type of error, you may need to fix it. You can click Fix All to handle all of the errors. In my case then, I will need to configure a few things, so I'll go to OpenXR. And then I just need to select Interaction Profile. And I'm going to select the Valve Index Controller Profile because that is what I am going to be using. If you're using one of these other ones, you would just select that, for instance, like the Microsoft Hand or the HTC Vive. That should be everything we need to do for the project settings, so now we can actually jump in and start configuring and setting up an actual scene. So for those of you familiar with Unity, you should recognize this kind of standard scene that sort of just loads in by default. We have a main camera and a directional light. We can actually go ahead and delete the main camera. We do not need it. The XR rig that we'll add in a second will have that. I'm going to just real quick add in some basic scenery. So I'm going to add in a plane. I will then add in a cube. This will serve as sort of like a table. So I'm going to actually scale this on the wrong axis, on the x-axis a little bit. Set that to 2. And then I'll add in another cube. Add in another cube that will be sort of like a smaller interactable object, which we will configure later on. Set that to just be a bit smaller, and then move that. I'm going to set it so it's above this table and kind of be an object that sits on top of that. So the next thing we'll need to do is actually add in the XR rig, which will sort of act as the actual player itself. So we'll come down here to XR. That should be an option you have now that we've installed all of the plugins. This is specifically provided by the XR Toolkit. And this is really useful because it provides a lot of the base functionality that we will need in order to just really quickly develop and prototype XR applications. So we have two different options. We have both device-based and action-based. It's recommended that you use action-based, as device-based will probably go away at some point. Right now, Unity is sort of halfway in between transitioning to action-based. Action-based is going to be using the actual Unity input system, whereas device-based is reading input directly from the device itself. So if we choose device-based, you'll see that you have a couple of different options here. You are still welcome to use those if you have a specific reason to. Otherwise, I do recommend using action-based. In this case, I'm going to choose the XR rig action-based, and it will automatically add it to our scene and kind of drop it right in here, and you can see the kind of green outlines here. Now if we click down, we'll see kind of how this is built. So we have the camera offset, which is going to be sort of your head position within those green boundaries. We have our main camera, which is why we actually deleted that previous one. And this is going to be a little different than most other cameras. I'm going to collapse these other things so we can take a look at this. There's a tracked pose driver, which is, they note it's using the new input system. And this is basically just tracking, okay, what input is being tracked here. We're tracking the eye position and the eye rotation. So this is actually updating the camera based on sort of where the headset is. Then we have a left-hand controller, which has a couple of different things attached to it. There's the XR controller action based script, which we will configure in just a moment. We have the XR ray interactor, and then we have a line renderer and a interactor line visualizer. So the line renderer and the XR line visualizer are just used to sort of show what your hand is pointing at. The ray interactor is what's actually interacting with things. It's worth noting that there are two different ways to actually interact with items using this toolkit. There's the ray interactor, and then if we come down here, we'll also have a direct interactor. You cannot have both attached to a game object at the same time, so you do have to kind of choose between one or the other. There are different advantages to each different one. The ray interactor is going to be casting basically an invisible line that's then visualized by these renderer components, these two renderer components down here. The direct interactor, you have to actually physically collide with and touch an object to interact with it. For now, I'm going to leave the ray interactor because it also allows for really easy teleportation and locomotion setup, so I'll just leave that as is. If there's some reason you need direct interaction, you would have to kind of build out separate locomotion systems. You can potentially piggyback off of what we'll be setting up in a bit, but just know that this is the easiest way to allow for teleportation. The right-hand controller is going to actually be more or less the exact same thing, just, named different. We will be configuring them slightly different, though. So if we go to this left-hand controller, we're going to want to actually configure the input actions. There is a default input system you can download through Unity. I'm going to actually show you how to configure these yourselves, just so you know a bit more about what's going on, though, and have a bit more control over that. So for position action, when you're going to click down here and choose Add Binding. This will add a binding path, and basically this is going to be where we define what input should this position action be reading. I'll then double click here, and under Path, I'm going to select XR Controller. And then since this is the left-hand controller, I want to select XR Controller left hand. And then in this case, since we're configuring position, I'll just choose Device Position. And then I'll click off to close that. So now what's happening is this position action is going to then look at and figure out wherever this left-hand XR controller is. We'll do the same thing for rotation. Choose Add Binding, double click, and then under Path, choose XR controller, left hand, and then in this case we're going to choose rotation, so it's gathering the rotation rather than just the position. So that will configure our controllers for, basically this will configure the controller to be tracked. We will need to do the same thing with the right hand, but in this case we'll be choosing, rather than the left hand path, we'll be choosing the right hand path. So XR controller, right hand, position, and then same thing down here, just choosing the right hand rotation instead of the right hand position. So controller, right hand, rotation. So now we have both the position and the rotation set up for both controllers. So if I were to jump into Unity right now with my headset, I would be able to see two disembodied lasers sort of just hanging out in space and following along with my hands, as well as being able to look around the scene itself. So now that I'm running the application, you can see that the actual view updates based on my head position, and I have two disembodied laser pointers that I can use to point at stuff. Currently there is no actual interactions being set up. We will be taking care of that next. So the next thing we'll need to do is actually configure the other actions in order to be able to actually interact with different objects. So in here we'll go to the left-hand controller first. We'll see that we have a select action, an activate action, a UI press action, a haptic device action, a rotate anchor action, and a translate anchor action. The haptic, rotate, and translate anchor actions aren't used nearly as often. Typically the main ones you'll be using are select and activate, as well as a few other custom ones. Selection you can think about as grabbing an object to choose that object as the thing you want to hold, and activate it you can think about as, if you want to activate that object after you've held it. The UI press is used to actually interact with different UI elements, which is a pretty typical and common use case within Unity. For instance, you might have like a scene menu and want to select, I want to load into level 1. You'll want to make sure that this is configured. So we'll go ahead and add a binding for all three of these, and then we'll configure the path. So for select action, I'm going to double click here, and for the path, I'm going to choose XR controller, and then in this case, it's going to be left hand, and then I'm going to actually choose optional controls down here. And you'll see here that we have a bunch of different options here. There's grip button, trigger button, all these other different ones. In this case, I'm going to want to choose grip pressed for the select action. So if I'm selecting something, I want to actually grab and grip it. For activate, I'm going to select down, add binding. Oh, I already added the binding. I need to double click on the binding, select path, go to XR controller, choose left hand, then choose optional controls, and in this case, I'm going to want to look for trigger pressed. So when the trigger is pressed, that'll be the activated state. For UI, I'm going to double click here, and I'm actually going to configure this to be the same thing as the activate. I'm just going to use the trigger for this one. So we'll choose XR controller, again left hand, optional controls, and then we will choose trigger pressed. So when I point at canvas and pull the trigger, it'll activate. In this case, it will be using the ray casting from the ray interactor to actually interact with the canvas itself. I will then do the same thing on the right hand controller. So we'll add bindings to all three of these, and then configure those. So now that we've had these different interactions configured, we'll want to actually be able to do something with it. So we're now currently getting that input, but we're not really doing anything with it. We don't have anything to interact with, and we can't really move around our scene. So the first thing I'm going to actually do is set up this second cube, this smaller one, to actually be an interactable object. So I'll just move my view around a little bit. And then in here, I'm going to want to choose interactable. So we have XR grab interactable, and then there's also XR simple interactable. In this case, I'm going to choose grab interactable. The difference is a simple interactable basically just says, hey, I can read this input. Grab interactable says, all right, cool, you can grab me, you can mess around with me, you can throw me, that type of thing. Simple interactable is useful if you want to make things such as buttons or levers or switches. Grab interactable is useful if you actually want to pick up the object. So I've added all that. It will add in, so it had the mesh in the cube mesh filter, but it's going to add in a box collider and a rigid body that are used for physics and actual collision logic. But then we also have this grab interactable, which has basically just simple logic for throwing and reactivating gravity. So this is taking care of a lot of different items for you. I'm going to go ahead and collapse that. So now this cube should be, we should be able to interact with it. If I were to jump in, I should be able to actually grab that object. So now that I'm in Unity again, if I point at this object, I can grab, and you'll see that the cube has now snapped to my hand. If I let go, it falls to the ground. Grab, snaps to my hand, drops to the ground. And you'll notice that my lasers, it's a little hard to see, but my lasers will turn white when I can actually interact with it. So you'll see this one has turned white when I point at it and red when I have it. And I can grab between the two. So the next thing we'll want to actually configure is the teleportation system. We have this cube now that we can interact with. If you wanted to, you could also add in custom logic for like an activation trigger. So you could grab it, and then when you pull the trigger, you could do something like change the color. If this was like a laser blaster, you could shoot a blast. If it was some other like technical equipment, like a drill, let's say, you could turn on the drill, those types of things. So you can add in custom logic on top of this. You can also do things such as volume triggers and collisions. So one project that the OVPR is working on, we have 2 different bins, and the user has to organize objects into the 2 bins. And if they drop, and so when the object hits the bin, it will delete itself, and then basically depending on what bin it hit, it will have some custom logic based around that. So you can do quite a lot with this. You can build off of it in the same way that you would with any other type of Unity. Raycast triggers, as we just demonstrated, also work with these types of things. So the next thing we'll want to do then, though, is add in some teleportation so that we can actually move around our scene. There are 2 different ways to teleport. There's anchor teleportation, and there is area teleportation. Anchor teleportation is a specific point within the scene that you add in. So we would create like an empty game object and say, all right, here's the teleportation point. Area teleport is going to be wherever your raycast has collided with. That's going to be the point it teleports to. So what we'll do is we'll select this plane, and we're going to choose add component, and we'll search for teleport, and we're going to choose teleportation area. So that'll make it so I can teleport to any point on this plane. You'll notice too, when I search for teleport, there's also a teleportation anchor. A teleportation anchor is going to be just that specific point that you can teleport to. So if for some reason you have a very specific area that they have to interact with, that's either for plot or for interaction purposes, that would be the best case to use that for. Otherwise, it's typically recommended that you allow people to sort of move around as they need. The other thing we'll need to do, though, is we'll actually need to configure our XR rig to take in and process teleportation requests. So in this case, we'll choose add component, and we're going to search for locomotion, and we'll choose this locomotion system. This is basically just going to say, okay, now this is going to move this actual XR object. You'll notice here too there is a XR rig that it's looking for. You can go ahead and assign this by clicking and dragging. Otherwise, it will automatically just find it at the start of the actual scene. It's typically best that you assign the reference right away, just for memory load and loading sake, but it's not required. The other thing we'll need to search for, if we search for teleportation again, is a teleportation provider. This is going to work with the locomotion system, as you can see here, which I will actually drag and assign right now, to basically process the teleportations and actually provide the teleportation system itself, thus the teleportation provider. I'll go ahead and save this, and now if we jump back into our demo project here, we should be able to point at any location, see our raycast turn white, and then teleport. Alright, so I'm back in the project. You'll notice my lasers are red, but if I point down, you'll notice they turn white. Again, it's a little hard to see, but now if I point and grab, you'll notice I am snapping around the scene. It is possible to configure this input. By default, it will just go to the grab action. You can change it to be the selection action if you want, and then our cube can still snap, and now we can teleport over to the edge and toss it off if we want. So that about covers it for this video. We've gone over quite a few different things, but these are sort of the building blocks to kind of build your own augmented and virtual reality applications. The benefit of using the Unity XR plugin and the Unity XR Toolkit is that it allows for a wide variety of headsets, as well as really quick and easy kind of building out of different systems. So hopefully this answers a bunch of your questions. Keep an eye out for future videos that help to run through, using Unity, coding in Unity, as well as some other more specific augmented and virtual reality topics.